Welcome back to All This Math. This is Professor Parker. Now, we got two examples up here, and we're about to do some factoring. All right? Always key in on what your instructions are. Always know what your instructions are. We are factoring. Now, this says DOTS. It's an acronym. It stands for the difference of two squares. All right? Now, what I like to do when my job is to factor is I look at the expression, and I first say, all right, I try to identify it according to how many terms it has. So I ask myself, is it a binomial? Is it a trinomial? Is it a 4-term polynomial? Or is it a 5-term or whatever? All right. This is a binomial. Binomials are expressions that are separated by a plus or a minus sign. So this is one term. That's another term. 1, 2, 1, 2. Two wheels on a bicycle, two terms in a binomial. This is a binomial. This is also a binomial. All right. Binomials have terms that are separated by a plus sign or a minus sign. All right. Now, if we're dealing with a binomial, all right, this is the next thing you got to know. You should probably take notes on this. So first, classify your expression. Is it a binomial? Is it a trinomial? Is it a 4-term polynomial? Is it got 5 terms, 6 terms, whatever, right? If it's a binomial, always look for a GCF no matter what type of term it is, no matter what classification it has, whether it's a trinomial, binomial, whatever. Always look for a GCF first. Beyond that, if it's a binomial, it might be a difference of two squares. So you should check to see if it's a difference of two squares. If it's not a difference of two squares, it might be a sum or a difference of cubes. A sum or a difference of cubes. All right? So when we're dealing with binomials, this is what we do. We checking for GCFs. We try to pull GCFs out. We got to identify a GCF and pull it out. If it is one, right? Besides one, because really, one is a GCF of everything, but one don't help us. So if one is a GCF, we don't care. In both of these expressions, one is the GCF. But don't nobody care about that, because that's not going to change nothing. That's not going to help us. Then we say, okay, is it a difference of two squares? And it is. And this is how I know. Because x squared is a perfect square. How do I know that? Because my exponent is an even number. Whenever you got an even numbered exponent, that is a perfect square when we're dealing with variables. I mean, we could think of 9 and apply the same rule to 9. 9 is the same thing as 3 squared. And 2 is an even number. So 3 to the second power is the same thing as 9. So we could also apply that rule to 9 also. Or you could just know that 9 is a perfect square because you know your perfect squares. You know 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25 and all that. So on and so forth, right? Y squared is perfect, again, for the same reason that x squared is perfect. So when you see a difference of two squares, and think about the wording should match up with what you see on your paper. Difference means there's a minus sign. Because when you subtract, you get a difference, right? Of 2. 1, 2. 1, 2. Not 3, not 4, not 5, but 1, 2. Squares. That's a perfect square. That's a perfect square. All of these terms are perfect squares. So that means that you can factor it this way. It's like an algorithm, right? It's just a setup. It's a basic setup. All you got to do, and this is arguably the easiest type of factoring. Some people might say reverse FOIL method, maybe taking GCFs, but this arguably might be the easiest type of factor. I mean, all of it is easy if you know how to do it. If somebody teaches you how to do it, it's all easy. If you don't know how to do it, it's all difficult. That's why you should come to the channel, because I'm going to teach you how to do it. And then everything will be easy. All right? So we got one set of parentheses and another set of parentheses. This is the setup right here. When you got a difference of two squares, that's all you do. You look at the first expression, take the square root of it. So the square root of x squared is x. So you're going to put x right here. You're going to put x right there. Then you go to the second term. You take the square root of that. 9y squared. The square root of 9y squared is 3y. Because the square root of 9 is 3. The square root of y squared is y. So that's 3y. So you're going to put 3y right there and 3y right here. You make one plus and one minus, and you are done. Now, sometimes what might happen is you might end up with another difference of two squares, but this is not the case here because that's not a perfect square. That's not a perfect square. All right, because that's got an exponent of 1, and that's got an exponent of 1, and 3 is not a perfect square. So that means we're done. This is the final answer. All right, now let's look at number 2. A squared minus 25b squared. Let's go through our checklist. It's a binomial, right? Does it have a GCF? GCF is 1, but 1 don't help us. All right, so we go to the next. Is it a difference of 2 squares? Difference of 2 squares. It is a difference. 1, 2. Are they perfect squares? Yes, yes, yes. We check off all the boxes. Since we check off all the boxes, now we set it up. We set it up with 2 binomials. Take the square roots. Square root of a squared is a. Put the a here, put the a here. Right? Just like the x and the x. What's the square root of 25b squared? Now, I know there's a minus sign in front of that, but we're treating it like it's a positive. We're going to treat it like it's a positive, all right, in case you was wondering. So square root of 25b squared is just 5b. So you put 5b right there and 5b right here. You make 1 plus and 1 minus. Now, normally, if you've seen any other videos like this, you notice how I put the plus sign first and the minus sign second. It don't matter. It don't matter. You can put the plus sign first, minus sign second, or you can put the minus sign first and the plus sign second. It doesn't matter as long as you got 1 of each. As long as you got 1 of each. That's all that matters. And that's the final answer. Because we have factored completely. Because we can't break this down no more. We don't have any GCFs. And this is not another difference of 2 squares. So that means we're done. All right? So some of the problems are very straightforward like this. Some of the problems are not. But this problem, or these 2 examples, were very straightforward like this. But you got to practice. You got to practice these so that way you'll know how to use the different factoring methods when you see the different types of problems. All right? Because it's really all about recognition. You got to be able to recognize them, and then you practice over and over, and then you develop your muscle memory, and then you be good to go. All right? See you in the next video. Peace.